Hello students, in this video I'm going to show you how to complete the week 6 midweek assignment. So this assignment involves the data set from the week 1 midweek assignment. So it's the one with age, height, sex, year in college. And keep in mind your data is going to be different than mine because remember everyone made up their own data. Now you should already have age, the descriptive statistics for age calculated, so you may not have to do this step. But if you didn't save that or you did not do it, you need to calculate the descriptive statistics for age. So you would click Data, and then Data Analysis, and then that's going to be Descriptive Statistics, and click OK. And then I've already been doing this a little bit today, so it remembered what I put in last time. But basically, you want cells B1 through B41. And in this case, we're not going to copy anything, so you don't actually need to put the dollar signs in. What the dollar sign does is if you're copying down the rows from a column, a formula, it would keep it set. It would keep the number set because it would just advance to the next row. So the formula would change. This keeps it fixed and it doesn't change. We're not going to copy anything, so we don't absolutely need it, but it doesn't hurt anything to have it. So you basically want those cell B1 through B41, and you want to make sure labels in first row is checked. And then just pick somewhere for the output range. You may have more in your file than I have, but just pick a clean space where you don't have anything and put where you want it to start that output. Then you just click OK. And like I said, keep in mind your mean for age is going to be different than mine because we all have different data that we made up. So what you're going to do for this assignment is you're going to conduct a one sample t-test, and you're going to compare the age of your sample to the age of the general population of college students. And so if you read the description of the assignment, it says assume the population mean is 21. So in one cell, you could just type T equals. And then going to the course resource, going back up a little bit, you can see that the formula for T is, so this is the symbol for the sample mean. So it's the sample mean minus the population mean divided by the standard error of the mean. So that's what we're doing with this. And so you'll have to type that. Don't type it in this cell where you put T equal, put it in the next cell. And so all you need to type is equal, and then within parentheses, you're going to type whatever your mean is. And you can round to 2 decimal places. So my mean is 24.25. And then we want to compare it to the population mean of 21. So it's minus 21. All of that's within parentheses. And then you want to divide by the standard error of the mean, which in my case is 1.24. So to divide, we use the forward slash and then type 1.24 and then hit enter. So our value for T is 2.62. And then you want to compare it to the critical value of T. And so what we want, this number needs to be larger. And in the case that it might be negative, just ignore the negative sign. And so that would be called the absolute value. So just the absolute value is when we ignore the positive or negative sign and we just look at the number. So you want the value that you've obtained to be larger than the value from the chart or the table. And the resource posted in the classroom talks about degrees of freedom. So degrees of freedom will always be n minus 1. So in our case, n minus 1, where n is the number of people in the study. So in our case, that's 40. So minus 1 equals 39. So n is 39 in this case. So going back to this resource, you can see that, and this is from the textbook, they've included a partial table of the critical values of t. And then because we're only predicting, or we're only looking at whether our sample differs from the population, we would use a two-tailed test. And that is because we're not predicting our sample is greater or less than anything, which would mean we're only looking at one tail or the other. We're just looking to see if there's a difference. So what we would need to do is, and I know you can't see this because the school put the red circle around the numbers, but our p-value is 0.05, so 0.05. And just by convention in psychology research, we usually use a p of 0.05. And so what you do, and you're going to need to explain this in the assignment, how did you determine the critical value of t? So basically you would follow this down until you get to your degrees of freedom. And now the problem with this example is that it only shows part of the chart or the appendix for the values of t. So what you're going to do is you need to go to the textbook. And so this is from the textbook. And you can see that we have degrees of freedom all the way, and you can see it starts out where it lists all of them, 1, 2, 3, 4, 5, and so on. But then when you start getting down at 30, then it skips to 40 and it skips to 60. So remember, our degrees of freedom, n minus 1, would be 39. So we don't actually have a 39 in the table. So we'll just go with the closest value. So that would be 40. But keep in mind that even though we're using 40, the reason why we're using it is because this table doesn't have a 39. Our degrees of freedom are still 39. So what you do is you find we want the proportion in two tails combined. We want to go to the 0.05 column and then go all the way down. Ideally, we would have degrees of freedom for 39, but we don't. So we're going to use 40. So basically, if you have the textbook open, you can just follow down with your finger or keep track of which column it's at. But our critical value of t is 2.021. And I'm just typing this in my Excel file so that I don't have to keep it going back and forth, so that I remember what it is. So remember what you're doing. You're comparing this to the value you calculated. In order for it to be a significant difference, this t that you calculated, this t value needs to be greater than this. And as we can see, it is greater. So 2.62 is greater than 2.02. So we can say that our sample mean of 24.25 is significantly different than the population mean of 21. Okay, so basically in the assignment, you're going to calculate this t statistic. You're going to use the 21 as your population mean, you're using your sample mean as to whatever you calculated. Like I said, that's going to be different for everyone. And you're going to write a paragraph to explain how you located and determined the critical value. And so you can replay this video if you need help. It's also explained in this PDF, but basically I told you that you need to know that it's a two-tailed test. You need to know that your value of p, so your p-value is 0.05, and you need to know your degrees of freedom, which in this case, n minus, oh sorry, I should have typed n minus 1, not equals. So degrees of freedom would be n minus 1, and n is the number of people in the study, and that's 40 minus 1 is 39. And then you would just go to the table like I did, knowing degrees of freedom are 39, knowing p equals 0.05, and knowing it's a two-tailed test, and you just look for it the way I described. Okay, so proportion and two tails combined, you would, and that's essentially the fourth column over, and you would just go down. You know, you could keep your finger on this column so that you keep track of it. And then because we don't have a 39, we would go to the closest number, which is 40. So our value of t, our critical value of t is 2.021. So you would have to explain that in words in a paragraph. And what you also need to do for this assignment is you need to write a one-paragraph APA formatted interpretation of the results, modeled in the example in the lecture. And so that's this week 6, compute a one sample t-test document. So it tells you exactly how to do it. So you would model what you're writing after this. So you would type results, center it, and then say something similar to this. You know, basically you conducted the one sample t-test to test the hypothesis that the age of your sample is different from the age of the general population, which is 21. Even though it doesn't mention that here, it'd be helpful to mention that. And then you report the results of your t-test. So it's t, and then, you know, don't use these numbers, use your numbers. So degrees of freedom for t would be 39. So instead of 11, you would type 39. So even though we use 40 from the table, don't type 40 here. Just type 39 because you're reporting your actual t statistic that you calculated, not the one from the chart. So t with 39 degrees of freedom equals, and that would be, in this case, 2.62. And then p less than 0.05. Because we say something is significant if it's less than 0.05. Typically. I mean, we could set other values of p, but as I mentioned in psychology, typically we use p as 0.05. And then within parentheses, you want to provide your sample mean and the sample standard deviation. There's a little error here because when you're abbreviating mean and standard deviation, the M and the SD should be italicized, but however you want to do that. And then we just say the sample were significantly older, you could say, or younger than those in the general population. In my case, my sample mean, they were significantly older than those in the general population. And so we say that the null hypothesis is rejected. So remember, the null hypothesis is typically a hypothesis stating no difference. And so our null in this case would be the sample mean is equal to the population mean. And so in this case, it is not, so we reject the null hypothesis. And of course, with this, you're going to include a properly formatted title page. And a lot of students have been making mistakes on that, and I have posted it in the classroom. For the midweek assignment, it also says move your Microsoft Excel output into a Word document. And really, by moving, just saying moving, all you need to do is just copy and paste this. So select what you did, and then just click copy and paste it into Word. That's all you need to do. So this shows that you calculated T. It shows what your T is. You've shown how you got degrees of freedom. And then you don't necessarily need to put the critical value of T. I just put that there because I was going back and forth between different screens. I just wanted to remember it. So that's basically the midweek assignment for week 6. And then if you have any questions about that, you can send me a message. But also I do encourage you to look at this document. It's the week 6 Computer 1 sample t-test. And it just goes over everything step by step with an explanation of everything. Okay, as I said, let me know if you have any questions.